podcast.
Welcome to Automated. I'm your host, Mark Verbenkov, and in this weekly podcast, we will be exploring the impact of emerging technology on jobs, society, as well as us, with business and technology leaders, researchers, and independent professionals across the world. So today's episode will continue the discussion of how artificial intelligence is being integrated into weapon systems and the military overall. So the discussion covers why AI should be adopted in the first place, potential issues with autonomous weapon systems, and what are some of the possible future scenarios of its implementation. My guest to discuss this is Chris Gentile, who is a former F-22 experimental test pilot with over 8 years in the United States Air Force, where he was also the commander of the only unmanned aircraft system production, test, and sustainment detachment. He is now the vice president of EpiSci and supports a dedicated team in developing, implementing, and deploying tactical AI, trusted, explainable, bounded artificial intelligence for real-time mission-critical applications. So EpiSci is a multidisciplinary technology company developing AI for mission-critical applications, including communications, networking, and autonomous systems. And we'll be hearing a little bit about it more in the podcast today. So the core technology, which we'll also get into, is called tactical AI, and this is a framework for building modular, high-performance systems which combine the performance possible from deep learning with assured safety and operational bounding, and an explicit, trust-first design, which is designed for manned-unmanned teaming in dynamic environments. For those of you that aren't super technical and don't understand everything about AI, don't worry. The conversation today is a little bit more higher level. We don't jump directly into all the technical aspects of AI. I think it's a really interesting discussion, and I'm very happy to have had Chris on to discuss a little bit more about how AI is being implemented in autonomous weapon systems. Chris, thank you very much for coming on to the Automated podcast today. It's great to have you here to talk a little bit about autonomous weapon systems and AI and how it's fitting into the military and some of the other things that we'll be talking about. So thanks again for coming on.
Thanks, Mark. Really happy to be here and excited to talk about this stuff.
Yeah, absolutely. So as I was mentioning a little bit before off air, one of the things that I do with all the guests that come on is try to get a little bit more of a kind of a human approach to who you are as the guest on the podcast. So what is it that was kind of motivating or interesting for you to get into the work that you do now?
So there's really two directions to come at that. The first is that my career in education to date has kind of exposed me to a broad set of topics that all seem to be converging just in industry right now on things that either directly or indirectly deal with artificial intelligence, machine learning, and increased automation. So, I was fortunate enough to be a fighter pilot in the U.S. Air Force for a while, and then progressed on to test, acquisition, and development, which obviously exposed me to a lot of technologies. And then personally, I'm an engineer by trade, not a computer scientist, but software has eaten the world and continues to. So no matter which flavor of engineering you study, you end up dealing with code, and you become exposed to the tools and techniques that AI is developing. There's not a single facet of technology really that's not being that either hasn't been impacted by or isn't going to be impacted by the tools and techniques that are coming out now. And then on top of that, when I look at like my time flying and things like that, I've been the beneficiary of a progression in the quality of the tools that we use to expand what humans are capable of doing. If you look at fighter aircraft that, I'll just speak to the US models, early jets were very, very challenging to fly. You really needed to have the right stuff just to maneuver and control that aircraft safely. And then we developed airplanes that were much easier to fly to free up the pilot in order to manage things like the radar or the weapon system. And then the last aircraft that I got to be involved with, the F-22, very much uses advanced software to manage a lot of that sensor management at a level below where I had to directly deal with it, and it let me spend my time focusing on tactics and strategy and managing the mission. you see a lot of press release about how an F-22 or an F-35 pilot is kind of a battle manager rather than just a fighter pilot. And if you look, that path is going to continue with current computer science and engineering, and that is all leading towards artificial intelligence, machine learning, and ways that we can help humans make better decisions and then act on those decisions in a more effective way.
Yeah, it's super interesting to hear that this is also within kind of the military, the Air Force realm, because the number of guests that I have onto the podcast, many of them point to this as well, right? Within their own respective fields, it's that there's this constant progression, and that humans are being freed up in a sense to work on things that are either more humane, right, more human to human interaction, or actually on the content and the things that interest them in the craft or in the work that they're doing. So I think it's also for me really interesting to hear that the same sort of trend is progressing in the Air Force at the very least. Yeah. But as we'll be talking about AI, autonomous weapon systems, one of the first questions that I have here, and I wrote it down and I sent it to you beforehand, is, why should we even be applying or even think about applying AI into weapon systems, right? This is typically the storyline of many of these sci-fi films, Terminator, etc., that come out of Hollywood, that ends with either the human race or the world kind of blowing up. So why should we be thinking about this, and kind of what are some of the benefits that are viewable in this pursuit?
Absolutely, it's a great question. I think that the industry and all of us as a whole do a disservice if we try to minimize this or shift it off. But I think it almost starts with a bit of a definition in terms, right? When we talk about AI defense applications, that naturally brings up the question of an autonomous weapon system, right? We immediately think, Terminator, Skynet, all that sort of stuff. When really, as I'm sure being part of this community, artificial intelligence and machine learning is not general AI. It's not, they're not necessarily the same thing. So if you start first that artificial intelligence, machine learning, reinforcement learning, and these type of tools are just an extension of software. They're ways to build software that handles complex information in ways that provides, either decision quality information or increased functionality on robotic systems and things like that. Then at one level, it just becomes a natural progression of that type of improvement in engineering that we've been talking about. Obviously, we have more automated systems, again, sensor systems that are more effective and present their information to the operators in a more natural and human interpretable way. We've already got weapon systems that have transitioned from unguided guns and bullets to different types of missiles that are able to seek out specific coordinates or adjust their aim points in order to minimize collateral damage, those sorts of things. So I would say that the industry as a whole is very much still in that area of building better tools. The idea that they would all come together to build a Terminator or something is worth thinking about, but I would say it's still very much in the realm of science fiction. And so that's the first answer to the question. The second is that, again, without making it a political discussion, I would say, anybody involved in defense applications or the armed forces of their particular country or alliance does so because they believe on the balance that their values and the things that their defense sector is protecting are good for the population and ideally for the human condition as a whole, a more stable world. And in that case, you would want that industry to have the best tools available. There are always guards, and there always have been. When you look at major changes in weapon systems throughout history, where as a whole, the globe decides, the appropriate limits and boundaries that should be placed on weapon systems. But what really excites me about this topic is the idea that it allows us to continue a trend, which I think has really been paramount for the last 20 or 30 years, which is a drive towards more selectivity and less collateral damage. That is not always a realized goal, But the bottom line is humans make mistakes. And those mistakes almost always come down to one of two things, or one of three things: not enough information, an improper interpretation of the information, or just human stress and distraction and emotion that impacted that. You could draw exactly the same parallel with self-driving vehicles coming out there. There's absolutely no doubt that a top of the line race car driver is going to be a better vehicle operator than an automated system for at least our lifetimes, right? To get out there. But there's also no doubt that sometime in the near future, you're going to reach a point where autonomous vehicles are safer on average than humans. And at that point, it becomes almost a moral decision to, allow that safety to be taken over there. So while there's always the risk of misuse, anything that allows an operator to make a better decision, whether that's about gauging relative threats, whether that's identifying combatants from non-combatants, or gauging the appropriate response and type of weapon to use, anything that offers them tools that can help them make better decisions there, we believe can achieve those defense goals with less impact and more humanity rather than the other way.
Yeah, I couldn't agree more with you. I also think the reason that I also asked this question, because I think that this is almost where many people's thinking stops, right? They've seen a couple Hollywood films. They might have seen a blog title or two, right? A header or two. And it's a sensationalized perspective of what the actual industry, of what the actual technology is. I mean, I'm personally, I personally hold the belief that, at some point in the future, we will most probably come across an AGI or build an AGI. But up until that point, these sorts of things that you were just mentioning are really the steps that are being taken right now. And it's not simply because we're on this path that AGI and the Terminator and Skynet and things like that will come out in the next year or so. There is actual use in bringing them out. Yeah.
Exactly. And one of the things, and I bet we'll circle back to this later, is that right now a lot of artificial intelligence work for defense applications is focused on one of two areas. That's either automating a specific physical system in order to achieve its task either more effectively or with less burden on the human operator. And then the other side is solving that information decision, the combat identification problem, prioritizing a threat or identifying combatants from non-combatants. There are definitely concerns if the idea becomes to plug those two together without a human in the middle. But everything, A, that we're working on, and B, that I've heard from the government, all the way from our senior leadership down to the offices who are actually setting requirements and funding research and development, all believe that we are looking at a future where humans sit either on or in the loop and use these tools to enhance our decision-making and execution capabilities.
Right. And this is something where Glenn Snyder, the one that put us into contact in the previous interview that I had with him, this was, I think, the point that he stressed, and I'm really happy to hear that you're also stressing that point, that humans are going to be in the loop, that it's not something that's completely automated out to an AI system or some sort of autonomous system that has that kind of ethical discussion point. But I think we'll get into that a little bit later. We'll be talking about some Slaughterbots ideas. I want to hear a little bit more about EpiSci, the company that you're with right now. I know that you're working, that the kind of the main product, the main thing that you have is tactical AI. So maybe you can talk to us a little bit about EpiSci, tactical AI, and what exactly it is that you guys are doing.
Absolutely. Thank you. So I joined EpiSci about a year ago, really to run a portion of our portfolio that deals with tactical systems. And I'll get into this a little bit more, but that was really based on our involvement with a DARPA program called Air Combat Evolution, which is designed to fundamentally increase trust in artificial intelligence among the tactical community in the fighter pilot in battle management community. Objectively, their role was not to build an unstoppable robot wingman, which if you saw the Alpha Dogfight trials last year, that was the headline, right? AI beats Top Gun 5-0. But fundamentally, the program was not about absolute performance. It was about taking AI through the same sort of training syllabus that human pilots go through right now in order to increase trust in these systems.
Mm.
So with that, that was a really natural fit to the tactical AI design paradigm that EpiSci had been using. EpiSci is a small AI-focused research and development company located just outside of San Diego, California. And when we talk about tactical AI, what that is it's a way that we approach the system design and architecture in order to break a system down to solve two main problems. The first is that managing what we call the sim to real transition in AI or reinforcement learning scenarios can be very challenging, right? Reinforcement learning, a couple broad flavors of artificial intelligence. Your machine learning is really your computer vision and things like that. Train it on 1,000 pictures of cats, and then it knows what a cat looks like.
Right.
Reinforcement learning is a little less data heavy, and it's a little more simulation based. And this is the videos that you've seen of, teach a robot to walk, right? By just spinning up a simulation, saying you get a point for every foot that this robot moves before the end of the scenario, and you let it run for what may be hundreds of years of virtual time. And eventually it learns to walk very well. And or in our case, it learns to fly a simulated fighter aircraft very well. But there's some risk in taking a system like that and bringing it out to the real world. Your simulator wasn't perfect. Your models, your actuators, your motors, and things like that don't necessarily work exactly how they were. And there's a risk of overfitting, which is a common term in artificial intelligence. The second large area is that it can be really expensive to do all the computation and all the simulation that you need to train something when even very small aspects of the problem set change. And so what we do with tactical AI is we build a system from top to bottom, and we only apply that reinforcement learning, the deep neural nets, things like that, where they're really going to matter. There are whole aspects, and I'll use the example of our AI for dogfighting case.
Yeah, please.
We know how to fly airplanes pretty well. There is, generations of aerospace engineers who've been designing control systems that say, if I want to turn an airplane at 10 degrees per second, this is how I move the flaps and the tail surfaces and those sorts of things. We know a fair bit about just the basic geometry of a dogfight to say, okay, I need to be maneuvering in relation to another airplane. There's a lot of angular and physical relationships that occur. Those things don't need a neural net to try to reinvent the wheel in those cases. So we take all those aspects of the problem off the table, and that gives us some resilience, right? It means that if I change the aircraft or change the performance of the aircraft, I can go talk to the guys who built the aircraft and say, okay, what kind of control system should I plug in? Where we apply the artificial intelligence, the machine learning, is really at like a behavior level, where it says, okay, there's a ton of parameters that come into play when I decide, what kind of maneuver I should do at this point in a dogfight. There's aspects of the relative performance of our aircraft, how we've been flying up till this point, who's above or below the relative energy states, all those things. And those are the areas where for a human to write old school, like 1970s, 1980s AI, where it's just a series of if-then statements or mathematical functions, it would become nearly impossible to get high performance out of a system like that. And that's exactly the area that neural nets and deep reinforcement learning excel at. And so that in a nutshell is what tactical AI is. We break a problem down. We try to isolate it as much as possible in order to minimize those sim to real and data requirements. And then we apply AI where it's needed with the system engineering that lets us, realize those benefits. The second example to that, or the second real benefit from that, is that a lot of these applications have some sort of like mission or safety critical feature to it. And in this case, I'll use the example of a self-driving car, right? There is, Tesla has some of the best computer vision and artificial intelligence engineers in the world, but I'm pretty confident, I obviously don't know, that their emergency braking system at the end of the day is a relatively hard-coded system that says, if we identify an obstacle that's this close to us and closing at this speed, hit the brakes. It's not a neural net that decides, whether to engage the automatic braking or fire the airbag. Those are deterministic rule-based systems. And when we break a problem set down with our tactical AI paradigm, it allows us natural interfaces where we can go put those deterministic safety bounds on. We can say, look, no matter what, you're not allowed to target an agent that's outside of this, target a sensory port that's outside of this geographic area. This is the hard limit on where you are. Doesn't matter what you think, what the neural net spits out, or, this airplane stalls at 150 miles an hour. You are not allowed to fly below 150 miles an hour.
Right.
And it gives us a very natural way to put those steps in. EpiSci as a whole, it's not just this, sort of dogfight problem. We have a series of applications across both, unmanned systems or manned-unmanned teaming, cognitive radio, which is using these artificial intelligence tools to improve bandwidth and performance of communication links. And then we also apply it to advanced network management. Again, a lot of defense applications there, but also a lot of civil. When you start looking at systems like 5G and eventually 6G that have really complex interactions with the environment, multi-static antennas, things like that.
Okay, and specifically with the collaboration that you had with Red 6, because I think some of the listeners would be familiar with that. The tactical AI that was used in the dogfight scenario. I remember Glenn was talking about how the AI was like when the interaction would start, sometimes the AI would just kind of ram into the other airplane. So these are the hard limits, the hard barriers that you were setting, saying like, okay, well, that can't be done because then it kind of defeats the purpose of this actual training simulation.
Absolutely. And, this will be one of those times where I explicitly state that I don't speak for DARPA or the government program managers running that. But the beginning of that Alpha Dogfight program, which ran last year, the program intentionally limited the scope and the complexity of that, really to serve as a proof of concept for if AI was ready for this type of task, this Hollywood Top Gun dogfighting task. And so some of those decisions were that they didn't apply all the same rules that we have in real life. Things like how close are two aircraft allowed to get to each other, or can you take gunshots head on, which in real life is a bad idea, not only for training safety, but also because I don't necessarily want pieces of another airplane coming off right in front of me when I'm flying at them at a combined closure of almost 1,000 miles an hour. The extension to that, the current DARPA Air Combat Evolution program does have those rules in place. And our agents, along with some of the other performers, because of this sort of structure, has been able to adapt to those rules very well. So as opposed to the ones that were publicized last year, what we have training and flying right now follows those. It doesn't close within a safety bubble of other aircraft. It doesn't take head-on ramming. The nature of tactical AI and what it allowed us to do was that when Glenn and Red 6 called up and said, we have this incredible AR training capability and we're ready to move on to an AI bandit, a reactive virtual opponent, we were able to adjust our system, which was built for that DARPA competition, to work within their limits and provide good training value. Now, again, not just be an unstoppable, robot dogfighter. We were able to make that change in just a couple of weeks. And that involved a change to the flight dynamics engine, change to the interface, the software interface, change to the performance characteristics of the aircraft to go from an F-16 for the government to the, propeller-driven aircraft that Red 6 uses. And so that was an incredible top-to-bottom test of our tactical AI system. Can we really deliver? Can it actually be as flexible and as robust as we said it is? And we were thrilled. And it sounds like Glenn felt the same way.
Yeah, absolutely. Definitely sounded the same. So is this, just to be super clear, this is then the path that EpiSci is on, right? It's to use this tactical AI to further kind of training simulations to understand within training scenarios how whatever situation, whether it's an air combat or potentially in the future on ground simulations, or is that a couple of years down the line still?
Well, I think expanding this particular technology or this particular application of our tactical AI, beyond the airborne regime, we have a couple experiments running now. In fact, we're even looking at ocean going or subsurface
Okay.
vehicles as well as ground stuff. But it's important to note that we have a great partnership with Red 6, but training is just one aspect. Fundamentally, we're working on building this performance that can be applied to the real world.
Mm-hmm.
In that feeds the Red 6 collaboration in two ways. The first is that there is a huge need for training. As Glenn mentioned, I'll just speak to fighter aviation, incredibly expensive.
Yeah.
For a wingman to go up and learn how to fight 2 blue aircraft against 4 red aircraft, that's nearly $250,000 an hour to generate that. So if I can take even half of those required aircraft, whether it's the other blue or some of the red, and remove the need to actually put them up there, put them at risk, be putting the wear and tear on the aircraft, et cetera,
Mm-hmm.
then that's a huge win. The second goes back to what I said. The DARPA program managers have told us their goal is, which is to increase trust in combat autonomy. In order to do that, we need to be able to expose the operators to it in training, in areas
Mm-hmm.
where it's not necessarily a real robot, where there's not necessarily real risk, and get feedback. First off, that just provides a level of familiarity for the operators. And second, as every software program that's ever hit the streets has discovered, is that your users are going to have, criticisms or find bugs that you are not able to find in training. And so what better way to get it out there than via that sort of virtual and augmented reality interface with the systems. That said, our end goal is really to, with this specific program, what we call our Alpha Pup agent, is to eventually be in a position where our fighter pilots may have one or more unmanned wingmen that solve a number of problems that they have. Maybe they're able to carry sensor packages. Maybe they're able to provide a defensive cover for other aircraft, things like that. And this is, there are a number of programs working on this. And the idea is that you can build a lower cost, and perhaps even what they say, attritable aircraft. One of the many drivers of how expensive a modern fighter plane is that it's designed to last between 8,000 and 10,000 hours, so that humans can go out and train with it for decades before they use it in combat. If we build smaller unmanned wingmen that are maybe designed for a 500-hour life, one of the corollaries to that is that you're not going to fire it up every day and let it go fly next to the humans who are training. So we need a way to be able to simulate and expose them to that without necessarily firing this thing up and launching it. And so that's one of the real applications for that virtual and augmented reality tech.
That's really interesting. Yeah. Maybe we can touch a little bit further on these autonomous wingmen. Right? This is something that's potentially coming out in what, 5-10 years time, 20 years time. Do we have a timeline for that? Generally, of course.
It's very tough to say.
Yeah.
Tactical aircraft development timelines, not only in the United States but around the world, are very tough to pin down. I would say that virtually every company or government working on this all feels that they need to go faster, but exactly how we get there or how fast it will be. But there are a number of prototypes flying today, and experiments being done. As an example, the DARPA Air Combat Evolution Program hopes to demonstrate a manned-unmanned teaming dogfight within the next 3 years, using full-scale aircraft that have been modified to allow the agents to operate the controls.
Okay, crazy. It's every conversation that I have on this podcast, it always makes me realize just how much sooner things are than kind of what most people are assuming. Very interesting. I think a connected idea to that is the cybersecurity issues, right? So if we are going to be seeing, just demonstration purposes, a manned and unmanned test in the next 3, maybe 4 years, what are some of the cybersecurity issues that are connected to that? This is, I think, something that comes up all the time in these kinds of conversations. Like, will the AI or the agent be hacked and therefore be turned into a red, as you were saying, if there are 2 blues flying side by side?
That's certainly a concern of everybody in the industry. And there's a lot of ways that we deal with that, from traditional cybersecurity tools, aggressive red teaming, good system design, all that. But, what I think matters the most to us and the things that we're talking about is that this is the exact reason why we are so far away. I can't say
Mm,
never because that's a big word, but why we are so far away from an autonomous weapon system. The idea that you can go outside of like radio or some other direct, highly assured line of sight communication to a human operator exposes you to all of those
yeah.
risks.
Mhm.
That is a huge reason to keep that human either in or on the loop. If this is something that's only a few miles away from me, maybe I can limit its data link to using something like a laser or optical communication system. Very, very difficult to jam, very, very difficult to hack or get in there. Obviously, you need to be on this, tiny little pencil beam that's running in there. And so that's one way that you deal with that sort of problem, is to always have a human who's close enough to maintain awareness and hit the red button and stop that from happening. If you start getting into the idea of, I'm just going to send these things out and tomorrow they'll tell me how the war went, you're opening up unbelievable concerns for cybersecurity, exactly what you mentioned. And so
Yeah.
that's another reason why we are so focused on that manned-unmanned teaming, where the human always has the ability to monitor the situation and intervene.
Okay. Yeah, I think that's again, this is one thing that I think is within the kind of public discourse, right? It's, oh, we're going to have humans in maybe one airplane and an unmanned plane right beside it, but then they'll just be hijacked and they'll blow each other up, right? It's something that maybe it's a bit how should I say, not a very well informed idea, but I think it's interesting nonetheless to have this kind of conversation, especially for people that might not be completely familiar with all the intricacies of the Air Force or the military.
I agree completely. I would say that cybersecurity in general is something that's both, more concerning than most people realize. Yet at the same time, we've, knock on wood, never
Hmm.
realized the true nightmare scenarios, right,
Right.
of everything going down. And um, that doesn't just happen. I think Elon Musk some years ago had a quote about technical progress, that in the modern time we've come just to take things for granted, right? That our phones are
Yep.
going to get smaller and
Yep.
everything's going to get better, and that's only the result of a huge number of talented professionals like getting up every day and doing their best to make that happen. And so I never want to take cybersecurity for granted. But the fact is that there's a huge number of very talented people working on this, and that assurance and being tested to some extent, the requirements go up as the risk goes up. And I believe that the type of systems we're talking about are always going to be at the very top end of that scale.
Great. Well, thank you very much for that clarification. That's that's good to hear. Um, Maybe we can move on. There's another part of EpiSci that I thought was quite interesting, which is Swarmsense. So this has to do with drones and not military aircraft where they're manned. Can you talk a little bit about Swarmsense, what it is, and then I think this will open up an interesting conversation towards Slaughterbots, which I've talked about on the podcast before.
Absolutely. So Swarmsense is our framework for multi-platform autonomy, and the most immediate application is with small UAS, quadcopters, things like that. It doesn't just have to be that; it works across heterogeneous mixes. So maybe some ground vehicles or fixed nodes, some fixed wing aircraft, some multi-rotor aircraft. But this is actually primarily focused on the civil market. And we believe that at least in the United States, the regulatory environment is going to become more and more willing to allow us to get away from a one-to-one operator to vehicle ratio. And so there are a number of applications that we think this are just incredibly excited for. Here in California, our last couple of years have just been unbelievably bad wildfire seasons.
Hmm.
And so there are a lot of unmanned aircraft, all the way up to like MQ-9 Reaper drones, large military drones, and those are huge airplanes, right?
Hmm.
They're nearly the size of a 60+ foot wingspan out there. But our vision for this sort of thing is that an on-scene commander shows up deep in the backcountry in California or Australia or anywhere else, is able to deploy a number of these aircraft. If their goal is to deal with a 10,000 acre region, then maybe, they do some quick math and say, okay, I can cover this. If I launch 12 aircrafts, I can get this covered quickly. And a single operator hits a single button, and these vehicles go, they maintain communication amongst each other, even as they go, around ridge lines, terrain masking, things like that prevent them from having radio communication back to the base. They collaborate with each other to effectively 3D map the area. They look for hotspots, and they report all of that back to where, now a firefighting commander can look down and say, okay, I've got a 3-dimensional map of the area. I know what the weather is like. I know where the hotspots or the highest risk is, and I can now, start deploying firefighters or, dropping flame retardant or something like that. We think the same applications are all over, like emerging air delivered logistics. If there's ever going to be a huge number of package delivery drones or anything like that moving around, there's going to have to be some degree of automated air traffic control that we just don't have right now, that this would fit into. But the overall idea is just, small UAS have revolutionized so many industry, right? Almost every large scale agricultural operation uses it to analyze their fields, use multispectral imagery to calculate, crop health, things like that. You've got utilities, like power distribution and stuff, road maintenance. They're all using these vehicles, but every one of them right now has a 1-to-1 operator to vehicle ratio, one pilot for one vehicle, sometimes even a pilot and maybe a sensor operator to deal with one vehicle. What Swarmsense does is it doesn't replace any of those single vehicle capabilities. There are incredible companies all over the world. Here in the United States, Modal AI and some others that are all part of the Drone Code Consortium, are able to build processing for vehicles that can navigate without GPS or, can operate around obstacles without hitting them. There's a company called manned-unmanned out of Australia that has this incredible drone-mounted LiDAR sensor that generates these incredible maps. It can fly through very small caves and things like that. We're not looking to replace any of those single vehicle capabilities. What we want is to build the glue that allows you to build a team of those capabilities, put it all together without having to have a whole army of drone pilots at your disposal.
Right. And I think that really fits into kind of the general theme of the podcast itself, which is the impact on jobs, right? So if you're not replacing the 1-to-1 ratio of man to machine, you're essentially enabling kind of one person to do the job of potentially several people. But I think also one of the other points that keeps coming up in the podcast is that with these kind of increased capabilities, it also enables more people to do that one job, right? So you might be, cutting back jobs in one aspect, but in another, you're actually enabling more people to do more of that kind of work. What are your thoughts on that?
I absolutely agree with your last point. I could pick any one of these example industries or vignettes and talk about how that progression has gone. Here in California, they use a lot of unmanned systems to inspect power lines, and those are tasks that were done manually, up until very recently by driving around, maybe even flying over them in manned helicopters, very highly trained people. I would argue that the capabilities have increased so much, and the benefit that the operators or that the utility operators get from this has increased so much that, although I don't know this for certain, I can't imagine overall employment has actually decreased that much. Instead of surveying every line once a month, now they're surveying everything once a week using a small army of drone operators. And so to some extent, we see and would hope that would continue along. But the other area, and this is really my personal feeling on this, not certainly not the government's, and not something I've really discussed with the rest of us at EpiSci, is I'm a bit of a sci-fi geek, right? Anybody who grew up watching Star Trek or something and seeing the replicator and this idea of a cashless society, at the end of the day, if we make more things happen with less human labor, I mean, human labor is the core of all costs, right? The idea that I need to take the product of a human's, blood, sweat, and tears
Mm-hmm.
to turn into everything that runs the modern world. Um, if we can make more available with less, human blood, sweat, and tears, that's a good thing. The corollary to that is that the social structures, whether
Yeah.
that's, universal basic income, some sort of dividends from automation, they of course need to keep track. It can't go to where one person, owns all the robots and everyone else is living at their whim. But at the end of the day, I think that if it takes less people doing dangerous or unpleasant jobs in order to maintain the modern world, that's an objectively good thing. We
Mm-hmm.
just need to
Mm-hmm.
work on the margins to make sure that people aren't left behind.
Yeah, I couldn't agree further with you. That was actually one of the main reasons, one of the main interests that I started this podcast, was to really start that conversation, or maybe deepen it or add to it, by looking at these interesting guests from across the world in different verticals that they're talking about. So really happy that that you brought that point up. um, one of the other things, maybe the final thing on that point, was it's also interesting how you were talking about these drone surveyors, right? Or the inspections, right? They're rather than once a month, it's to once a week. I also think that in other industries, it's not just that they're doing more of the same task, but that they're able to do that task, but then also then focus on another part of the work that maybe they only did 5 to 10% of their job before. So I really see that these sorts of automation technologies, yeah, they automate a certain part of the job, but I think one of the key terms here is augmenting, right? It augments humans' capabilities to do more, maybe higher level thinking or more humane tasks where they're actually able to interact with their colleagues more or clients more. It enables more of kind of the human glue in society. Irrespective, I mean, we don't need to go into the UBI discussion too much, but I do want to bring that point up. Yeah.
No, absolutely. And that wraps back to one of the first things that we spoke about earlier, which is this extension of the tools that are available to humans, right? Just
Mm-hmm, mm-hmm.
making, freeing us from doing repetitive manual tasks or, simple information processing tasks that can be handled, and allowing us to apply our creativity and efforts in ways that are more impactful. And again, at EpiSci, that's, Swarmsense, it's a little bit different than, my background with defense and stuff, but it's one of the most exciting things because we really are trying to build an accelerator kit to help other people solve their problems. The idea here is we can provide either a software or a software and hardware solution to industries that maybe we at EpiSci don't have any exposure to, but we can help provide that glue to make other systems more effective. So we're really excited about that. Again, there were limits on the regulatory environment and the ability of individuals, especially non-government entities, to operate these sorts of multi-vehicle systems. But we think that's really turning a corner, and so we're very excited to get that out there. We've actually just done a public launch of that within the last couple of weeks.
Great to hear. So I think it would be remiss to not bring up the other topic. So this is that we've just discussed the very positive, beneficial
Yep.
side of things, but I also think also because it was so it went so viral several years ago, right? The Slaughterbots video that was part of the, I guess, movement to ban autonomous weapon systems. As part of that, showing the potential social ramifications of autonomous drone, right, or killer drones. Can maybe you touch on this, and specifically if it has impacted the work of EpiSci dealing with Swarmsense at all?
Well, so I'll answer the last part first. In
Mm-hmm.
that, again, Swarmsense is so far from the type of end-to-end AGI solution, right? Swarmsense is you can think of it as a software development kit, although we offer hardware if the host vehicle doesn't necessarily support our software capabilities, that just manages things like, can I maintain communication in a reliable way? Can I
Mm-hmm.
effectively allocate the motion of these to accomplish the mission that's been tasked to it? The Slaughterbots video was really interesting and brings up a lot of conversations, both good and bad. I know that especially in the defense line of work, a lot of people have really poked at some assumptions or assertions that it made, and all the reasons why they said it's not realistic. And some of those are just the ability to manufacture at the scale that video was talking about, whether or not that level of technology is actually possible, or whether that would even be an efficient way, for like the terrorist groups in that video to accomplish their tasks, right? In general, bad actors tend to do the least expensive way to cause their trouble, not the most expensive. But rather than that, I want to focus on something that I think is a good conversation that it brings up, which is, to me, the core. The little drone that they had in the video was what got everybody to look at the video, right? Because it's science fiction, it's cool. But to me, the real thing that they were bringing up to discuss is like exactly the same as in the Captain America Winter Soldier movie. If you replace the little drones with the guns on the helicarriers, it was exactly the same thing, right? It was this idea of a global threat identification feature that used things like social media, political ideology, facial recognition, and plugged all that directly into an end effector. Whether it was the guns in the Marvel movie or the Slaughterbot drones in that video. And again, going back to something I said at the very beginning, everything that we're working on is intended to have a human in or on that particular connection. It's one thing to use technology to help people make better decisions about how to allocate force, and it's another to use technology to affect those decisions, in a more effective way, and ideally in a more selective, lower collateral damage type of way. The question about plugging them directly into each other without a human with their hands on the go button is, I think it's a great conversation to have. Luckily, I think we're very, very far away from that. And I would agree. I think that there's, again, out of, at least in the United States, all of the senior leadership has been very explicit that those two things will not be plugged into each other in order to realize that. But it's a great example of what can happen there.
Yeah. Well, I think it's great for me to hear, but it's also, I think, good for the listeners to hear confirmation on that point that Glenn made in the previous podcast episode. That there is no there's no like specific desire right now to have those autonomous systems take control of those ethical situations. Whether that happens, go ahead.
Oh no, and I would argue that honestly, it opens at a large scale. It opens more risk to take those cases. When Dan and I flew fighters, the most significant aspect of a debrief was if there was ever what we called a fratricide situation, right? Like if you accidentally, took a simulated shot on a blue player instead of a red player, or, and this is significant, if you took a shot on what somebody who may have actually been a red player, but based on the information you had in your cockpit, you shouldn't have been able to know that. Like getting lucky didn't count. We treated that just the same. And so those sorts of questions are really significant. But the fact is it doesn't help anything to open yourself up to that sort of risk. And humans make these sorts of mistakes all the time, or not all the time. I'm sorry, but in the past, humans have made these sorts of mistakes. In 2003, Patriot missile systems mistakenly fired upon U.S. Navy and British aircraft. Obviously, if you reach back, some years before that, there was the shoot down of the airliner in the Persian Gulf. Even more recently, there was the Iranian shoot down of their own airliner based on exactly these sorts of mistakes. So it's not like we're talking about a fundamentally different type of problem. Again, just we need to be cognizant of the ability to make mistakes faster. and guard against that.
Great. Yeah, and I think that this is, as we were discussing before recording this, this is really what, like the Slaughterbots video or other maybe cultural or artistic pieces really try to bring about. It tries to bring about this conversation. It's not specifically stating that this is the eventual situation that will happen, but it enables a conversation so that maybe people who did have a worry about this before can get a little bit more information as to what is the actual state of things, and has people that are working in defense industry or military industries give them the opportunity to voice the actual real situation, the kind of on the ground reality that many of us might have been concerned about before. So I think for that reason, it's great to have you onto the podcast to kind of really solidify these ideas that they do exist in the realm of creativity and imagination for the most part.
Yeah, one of the ways that I look at it, I've mentioned self-driving vehicles a little bit, and I'm sure you're aware of all the trolley problem type issues. If the car's brakes fail, should it hit one person or should it hit five?
Mm-hmm.
In every comment thread that ever on any blog post that's ever brought that up always goes down the same thing, which is that this is a philosophical thought experiment that has nothing to do with the real engineering. The answer is that the car is going to stay within the lane, brake as hard as it can, and if it hits anything, it's going to hit it as slow as it possibly can, which is honestly all you could expect, even from a human in that case. The answer isn't to go and build all the rules for all the possible permutations of the trolley problem. The answer, or the real goal there, is to have that broader conversation about, okay, when an automated fleet is on average safer than humans, when's the appropriate time to start rolling it out? How much safer does it have to be? What kind of artifacts do I need to prove that? And to start that sort of conversation. It's not about, do I hit the one person or the five people, because that's, I knock on wood, that exact situation will never occur, but it does start a broader conversation. We're always happy to be a part of that conversation.
Great. Happy to hear. I do see that the time is winding down here a little bit. So one of the things that I typically like to end the conversation on is a little bit more of the future vision of whatever it is that we're talking about in these episodes. So I think we've actually touched on it a number of times in this conversation, but maybe I'll just give you the floor to, I don't know, put the nail in the coffin for what is the future of AI within the military, the Air Force, and defense in general.
Again, I'll go back to kind of my two main themes, right? That the AI is going to be used to process information and help humans make better decisions. While this isn't necessarily our focus at EpiSci, we're a little more on the second part that I'll talk about in a moment. There is a lot of people out here. This idea of decision science, decision augmentation. In this, I mean, this could be a whole nother podcast in your broader question of what does it mean for employment in industry. Is, when information tasks become more automated, where does human creativity and interaction work? The nature of those systems, there's been a lot written on. They're incredible research that's been done on how to find and eliminate biases, how to guard against them, what type of training humans that are working with these decision aids need, as opposed to their previous training, which was just on the exact data. The second area is on continuing to make our tools better, so that when a human or group of humans makes a decision, that they can affect that decision in the real world, as effectively as possible. And that's really where we see our focus going. Increased capability in robotic and autonomous systems, almost always as parts of manned-unmanned teams, that extends the reach and the effect of that human. And again, I go back to the aircraft that I flew in training. A 60-year-old T-38 took most of my effort to just fly the aircraft. It had some areas of the flight envelope that had some relatively poor handling characteristics, and you learn to deal with that. All the way up to the F-22 that I flew last, it was unbelievable. You had the power and the kinematic capability to send this machine almost anywhere you could think of. The computers running the flight controls kept you out of trouble. And the sensor suite, gave you this absolutely unprecedented insight into the airspace around you that took hundreds and hundreds of hours in older aircraft to get the same level of capability that you had your first day in the F-22. And so we just see that continuing. Now, that single operator will have the ability to look at things from multiple viewpoints because he has extensions of his aircraft that are flying alongside with his or her aircraft that are flying alongside them that are able to execute other tasks and distribute that.
Perfect. Well, Chris, I think that's a great way to end the discussion. I really want to thank you for coming on, solidifying and really clarifying some of the points that had been brought up in previous episodes, and I think expanding a little bit on some of the topics that we talk about here on the podcast. So, thank you very much. I will have the EpiSci website up on the show notes. Is there any other way that you want people to get in touch with you, follow the work that you and your company are doing?
Really between the website and then I'll send you some LinkedIn links as well. And that's the best way to stay in touch with us. And significantly, I'd be remiss if I didn't say that if anything that we've talked about interests you, especially on the idea of reinforcement learning, managing that sim to real transition, and taking some of these techniques and bringing them out into the real world, please get in touch. We're always interested.
Perfect. Great. Well, thank you very much, Chris. Much appreciated. Thanks for coming on to the podcast.
Thank you, Mark. It was a pleasure.
Well, that's it for this week's episode. Thanks for listening. If you like what you hear and you want to support the podcast and the conversations here, the best way to do this is to go onto Apple Podcasts and leave a review, as it helps the algorithm to reach out to new listeners and brings the show to them. Also, feel free to check out the website, automatedpodcast.org, where you can find the show notes for each episode, written articles on the themes of the podcast, and a library of resources on the topic of emerging tech and automation. Also, if you want to reach out and leave any feedback or you have any questions about the podcast or any of the conversations, there are general contact links such as email, LinkedIn, Twitter, etc. for you there on the website. And finally, for those of you that want more than just an audio conversation, the video recordings are now going to be up on YouTube for the newer conversations, so feel free to check out the videos by searching for Automated Podcast on YouTube, where of course you can like and subscribe if you prefer to support the podcast that way.
The Automated Podcast.